Hey there, Miss Lawson students. This is Miss Collins. I'm going to walk you through some notes on sequences and series. This is information that you just need if you're going to be taking calculus, either AB or BC next year or down the road. And a lot of this you hopefully remember from Algebra 1, but some of it will be new information. So, all right, so we know from algebra that a sequence is going to be an ordered list. And a finite sequence can be represented by the listed numbers. We know the word finite means like there's an end to it. So this sequence would only be made up of these 5 terms. However, an infinite sequence goes on forever, and you can tell this one is infinite because of the ... We represent the terms of a sequence often using the letter A and then the number of the term. So A sub 3 is just the 3rd term. You could use A sub n to represent any term, and then if I want to say the 100th term, I would just say A sub 100. All right, I'm pretty sure you know that so far. There's 3 ways we can define a sequence. Number 1 is we can just write the numbers, like the first several terms in the sequence, and if the pattern is something that's fairly obvious, like this one, where adding by 2 each time to the previous term, that will often, be easy for people to follow. But 2 things that I hope you remember from Algebra 1 is that we can write what's called an explicit formula. So an explicit formula is where I could plug in the value of any term that I'm trying to find, represented by the letter n, and I can find that term. So if I want to know what the 6th term of the sequence will be, I could plug in 6 for n, so a sub 6 is 2 times 6 minus 1, and that's 12 minus 1, and that's 11. And so it's natural to us that 11 would be the next number in our sequence. And then lastly, the recursive formula that you also learn about in Algebra 1. A recursive formula depends on the previous term. So instead of it being explicit, where you can just plug in the term you want, it really describes the change from one term to the next. You can tell a formula is recursive because you're going to be always given a term, usually the first term, and then in the formula itself, there'll be reference to either the previous or the next term. So if the term I'm trying to find is a sub k, the previous term is a sub k minus 1. So to find the next term in the sequence, you have to know the one before it in the recursive formula. So since I'm given that a sub 1 is 1, to find a sub 2, that's going to be a sub 2 minus 1 plus 1. Well, a sub 2 minus 1, that was just a sub 1. Oops, sorry, plus 2. I messed that up, sorry. So anyways, a sub 1 we were given, we're told it's 1. So then to get to a sub 2, I would just have 1 plus 2. My second term is 3, which we already knew because these are both the formula for the sequence. All right, we're going to work 3 examples. What I would do if I were you is I'd stop the video here, I'd work the examples, and then just check yourself watching the video. All right, so in example 1, we are asked to find the first 5 terms of the sequence, and we are given an explicit formula. I know it's explicit because there's no reference to a previous term, and I'm not given like any information about the first term. So to find the first term, a sub 1, I just replace or substitute rather 1 for the value of n in each time. So negative 1 to the first times 2 times 1 minus 1. All right, so we know negative 1 to the first is just negative 1. 2 times 1 is 2. 2 minus 1 is 1. So we get that a sub 1 is negative 1. All right, so for a sub 2, we're going to do the same thing. Negative 1 squared times 2 minus 1. Negative 1 squared is positive 1. 2 times 2 is 4. 4 minus 1 is 3. We get positive 3. All right, so then a sub 3, we've got -1 to the third times 2 times 3 minus 1. So that's going to be -1 times 6 minus 1. All right, so a sub 3 is -5. All right, so we could continue this pattern, and each time we're substituting the term we want for n. So as you finish this for a sub 4, you should get +7. And for a sub 5, you should get -9. Excellent. All right, in example 2, you're asked to find the first 5 terms of the sequence defined by, and now we're given a recursive formula. A sub 1 equals 5, so we're given the first term, and then a sub k is going to be 2 times a sub k minus 1 minus 3. So if my first term is a sub 1, my second term is a sub 2, and that's going to be equal to 2 times, I'm going to just fill this in kind of as it's written, so a sub 2 minus 1 minus 3. Well, 2 minus 1 is just 1, so this is just showing me that I'm going to take my previous term, multiply it by 2, and then subtract 3. All right, so we know that first term is 5. So to get a sub 2, it's going to be 2 times 5 minus 3. So that's 10. 10 minus 3 is 7. All right. A sub 3. So I'm going to go 2 times my previous term. This time I'm going to use my second term. So 2 times 7 minus 3. So 14 minus 3, a sub 3, a sub 3 is 11. All right, a sub 4, same thing. 2 times my previous term minus 3, 22 minus 3, a sub 4 is 19. And then you'll do the same thing with 19 to get a sub 5 is 35. All right, let's take a look at this last example. In example 3, you're going to find the formula for the nth term of the sequence. So now we are given the sequence itself, not a formula for it, and we are going to figure out like how to essentially write an equation for this. So the perspective that I have as someone who teaches Algebra 1, because I do not teach Algebra 2, what I notice is that this is a geometric sequence. Remember, a geometric sequence is when we notice that there is a common multiplier where you can multiply a term by that number to get the next term. So if you notice a division pattern, it's still geometric because we could just multiply it by the reciprocal. We associate in Algebra 1 geometric sequences with exponential equations and functions, whereas arithmetic sequences, when you're adding the same term or the same number to each term, that's going to be represented in a linear fashion. So for example 3, we're finding a formula for the nth term of the sequence. The way this is worded, the way it says for the nth term, this is how we know we want an explicit formula. All right, so what I would probably think of first is how are these numbers changing? You might notice they're being divided by 2, which is the same as multiplying by 1/2. So if you remember from Algebra 1, when we want to write a exponential function, we often use like y equals the y-intercept times the growth factor to the power of x. Well, this is actually going to be very similar to this. If I think about this being my first term, my second term, my third term, if I want to follow this structure, I would need to know my 0th term. I would need to know the term that comes before 40. So I know 80 is the number that would come before 40. So one thing I could do is I could structure it that way, like with what we learned in Algebra 1. So I could say that 80 times, in this case, the equivalent of our growth factor would be 1/2 to the power of n. So that's a sub n equals 80 times 1/2 to the power of n. All right, so now let's test this. If I want to find the third term, I should just be able to plug 3 in for n. So a sub 3 should be 80 times 1/2 to the third power. All right, so 1/2 is 1 cubed over 2 cubed, or 1/8. So 80 times 1/8 is in fact 10. So it checks out, it works. However, a criticism of this formula, not that it doesn't work, but sometimes people want to actually see that first term in there. Like 80 is never actually a term in this formula. So a term in this sequence. Oh, words are hard. It's the end of the day. What you could do though, is we could rewrite this to have the number 40 in it. So if I think about this, this was to help me kind of get my 0th term. If I'm starting at my first term, if I consider the same formula for just a minute, if I did this, if I said a sub n equals 40 to the 1/2 times n power, that wouldn't work, because when I plug in 1, I would get 40 times 1/2, which would be 20. But what I could do is I could say to the power of n minus 1. So now when I plug in 1 for my first term, 1 minus 1 is 0, 1/2 to the power of 0 is 1, and then 40 to the power of, 40 times 1 is just 40. So I could do that, and I would get for a sub 1, 40. So I think that this is most likely what you're going to see in like an algebra or Algebra 2 textbook. But these are really different iterations of the same formula. One of them is going to actually have the number from the sequence in it. All right, the next video is going to take you through the back of the notes.